Hello, and welcome to Boring Science for Sleep. Here, the universe speaks softly, and every word is meant to help you rest. Tonight, we'll wander into a question that feels both human and impossibly vast. Can the universe remember its past? We think of memory as something that belongs to living minds, scraps of moments we carry in quiet corners of ourselves. But look up, and you'll find the sky is full of reminders. Light from stars that no longer exist, faint radiation from the universe's first breath, ripples in space-time from collisions long since ended. The cosmos is old, older than any mountain, older than any sea. It has seen beginnings and endings, on a scale we can barely imagine. And yet, like us, it carries traces of where it's been, some clear, some fading, all still drifting in the dark. What time is it where you are right now? And when you look at the night sky, does it feel like the universe is looking back? So, settle in. Let your own thoughts slow to match the stars, and together, we'll listen for the quiet memories of everything. If you walk through a forest at dawn, you might notice the dew on the grass, the faint warmth on a rock from the day before, or the bend of a branch where something passed in the night. These are not the events themselves, not the footsteps of the deer, not the song of yesterday's wind, but they are signs, small, quiet remnants, that say, something happened here. The universe is filled with signs like that. It does not write its diary in words. It does not store photographs in drawers. Instead, it leaves traces in light, in motion, in the silent stretching of space itself. And for those who know how to listen, these traces tell stories of what has come before. Consider the starlight you see tonight. It does not belong to this moment. Every twinkle that reaches your eyes has traveled for years, decades, sometimes centuries or millennia, before arriving. When you look at the North Star, you are seeing light that began its journey hundreds of years ago. When you gaze at the Andromeda galaxy, you are catching a glow that set out more than 2 million years in the past. The light is a message, not in words, but in presence, saying, I was there and I saw this. Even in the empty stretches between galaxies, there are marks of the past. A soft bath of microwave radiation fills every corner of space, left over from when the universe was only a few 100,000 years old. It is cold now, its temperature barely above absolute zero, but it hums with the memory of heat from a time before there were stars, before there were planets, before there was anything that could look back and wonder. On some nights, scientists tune their instruments to capture the faintest of whispers, ripples in space-time called gravitational waves. They are born from colossal events, black holes spiraling together, neutron stars colliding, things so far away and so long ago that even light is slow to bring the news. Yet space itself carries their memory, stretching and compressing ever so slightly. As the wave rolls past, the universe also keeps its records in matter. Atoms forged in the first moments after the Big Bang still flow through the cosmos. The carbon in your body, the oxygen in the air, the iron in your blood, each carries a birth certificate of sorts, signed in the heart of a star that lived and died long before our sun was born. If you could trace each atom's path, you'd find yourself moving through an ancient web of creation and destruction, spanning billions of years. Galaxies themselves wear the marks of their past. Some are smooth and symmetrical, others scarred and warped from past collisions. Their shapes are silent testimonies to encounters long over. No one saw those galaxies merge in real time, but their arcs and spirals hold the memory still, the way a coastline remembers the tides. On our own planet, the evidence of cosmic history lies beneath our feet. Tiny grains of dust from space settle into the soil. Meteorites carry minerals older than the Earth itself. These small visitors are not just rocks. They are messengers from the earliest days of the solar system, holding chemical patterns that whisper about the cloud of gas and dust that became our sun and its planets. But perhaps the most haunting traces are the ones so faint they almost disappear. faint radio emissions from dead stars, ghostly glows from galaxies too far to see in detail, or the shifting dance of a star tugged by something invisible. These are the marks left not by what is here, but by what is gone. They are the footprints that remain after the traveller has vanished over the horizon. The universe cannot choose what it remembers. It does not keep the moments that were beautiful and discard the ones that were not. It holds all of them, impartially, like sediment at the bottom of a river, layering one era upon another. Some memories are clear and sharp, like freshly written ink. Others are blurred, fading as cosmic winds scatter them. And yet, here we are, creatures with eyes and tools, reconstructing these scattered clues into a story. We are, in a way, reading the diary of the cosmos, even if the ink is made of starlight and the pages are made of time. Out there in the dark, the past is not gone. It drifts, it glows, it hums. Everywhere you look, you are seeing a little bit of before. Even this very moment, as your eyes take in these words, is already on its way to becoming a trace, a small ripple in your own corner of the universe. And so, to ask whether the universe can remember its past is not just to ask about astronomy or physics. It is to notice that in this vast expanse, nothing is truly lost. It changes, it fades, it transforms, but it leaves something behind. Somewhere, light from this second is already racing away, off to become someone else's trace in the dark. If you close your eyes and listen carefully, you can still hear a room long after the people have left it. The air keeps its warmth for a while. Dust swirls where footsteps passed. The faint scent of something lingers, tea perhaps, or rain on fabric. These are not the moments themselves, but what's left behind. The universe too has such lingering traces. One of the most profound is something called the cosmic microwave background, or CMB for short. It is the oldest light we can see, a soft afterglow from a time when the universe was very young, not the first heartbeat, but the echo that still hums in the dark. More than 13 billion years ago, everything you now know, every atom in your body, every drop of water, every mountain, every star, was packed into a glowing, dense fog. It was so hot then that light could not travel freely. Photons, the tiny packets of light, were trapped, bouncing endlessly off particles of matter like sunlight caught in a thick cloud. For hundreds of thousands of years, this was the state of things. A universe so bright with energy that it was opaque to its own light. You could not have seen your hand in front of your face, if faces or hands had existed then. The cosmos was not yet transparent. It was a glowing sea, restless and young. And then, something happened. The universe expanded. It cooled. And one day, or rather, one stretch of cosmic time, the fog lifted. Electrons settled into orbits around atomic nuclei, forming the first neutral atoms. The photons were finally free to travel, released into the open space. That release was the first great flash of light that could move without being scattered at every step. And those same photons are still moving now, crossing billions of light years to reach us. By the time they arrive, they are no longer the fierce, blinding light they once were. They have been stretched by the expansion of space itself, their waves elongated into the gentle hum of microwaves, a form of light invisible to our eyes, but not to our instruments. In the 1962nd, two scientists, Arno Penzias and Robert Wilson, were working with a large radio antenna in New Jersey. They were not looking for the oldest light in the universe. They were simply trying to eliminate a strange, persistent noise that seemed to come from every direction, day and night, no matter where they pointed the antenna. It was a hiss, like static on an old radio. They thought it might be interference from the city. They thought it might be a flaw in the equipment. They even considered the possibility that it was caused by pigeons nesting in the antenna's horns and so they cleaned them out, twice. But the hiss remained. What they had found, without knowing it at first, was the faint whisper of the Big Bang, the cooled, stretched light from the universe's first free breath. It was everywhere, because the beginning was everywhere. No matter where you look, you are looking toward that moment. The cosmic microwave background is astonishing, not just for its age, but for its detail. At first glance, it seems uniform, the same in every direction. But look more closely, and you find tiny variations, slight differences in temperature and density, on the order of a few millionths of a degree. These are the seeds from which all structure in the universe grew, the places where matter gathered just a little more than average, eventually becoming galaxies, stars, planets, and, somewhere, us. When scientists map the CMB, they are not just making a photograph. They are making a time capsule. It is a portrait of the cosmos when it was only about 380,000 years old, an infant in cosmic terms. Imagine a human life captured in a single baby picture, and then imagine that picture containing every subtle clue about the adult to come. That is what the CMB is for the universe. Even its color, not that we can see it directly, tells a story. Once blazing white-hot, it now corresponds to a temperature of about 2.7 Kelvin, just above absolute zero. Its wavelength has shifted into the microwave part of the spectrum, gentle and cool, but still carrying the fingerprint of the moment it was set free. There is something deeply moving about this. Light that has traveled for over 13 billion years now falls into the waiting hands of our detectors. It has crossed the gulfs between galaxies, slipped through the tides of expanding space, dodged every obstacle simply by passing around it. It arrives without hurry, its message unchanged. This is where we began. And when you think about it, the CMB is not just a fossil of light, it is a fossil of time. It comes from a moment when time itself was young, when the first chapters of the cosmic story were just being written. It is the earliest memory we can touch, the farthest we can see into the past, without leaving the safety of our own orbit. Perhaps the most humbling thought is this: the CMB is not fading away. It is still here, filling every space between stars and planets, washing over you right now, as gently as starlight and as constant as the pull of gravity. You carry it with you in every breath, bathed in it without ever feeling its presence. In this way, the universe's oldest light is not a distant relic, locked away in the far reaches of space. It is here. It is always here. A quiet reminder, woven into the background of everything, that the past is not truly gone. When we study it, we are not just looking backward. We are holding the threads that connect us to the beginning, threads that run unbroken from the first free light. To this moment, right now, in the dark, as you listen. Some stories are told in words, others in pictures, and some in a language so subtle it can only be read with the patience of light years. The universe keeps many of its secrets in chemistry, not the kind you learned by memorizing tables in school, but a quiet ancient chemistry, etched into the very atoms themselves. It is a language that doesn't fade with time, a script written in patterns of light and matter, stretching back to moments long before there were eyes to see it. Every star is a storyteller, not just in the way it shines, but in the way it's built. The sun, for example, is mostly hydrogen and helium, the simplest and oldest elements in the universe. Those two, hydrogen, born from the Big Bang, and helium, forged moments later in the same primordial fire, are the foundation of all cosmic matter. They are the first words ever written in the universe's language. But stars are not content to stop at the first sentence. Deep in their cores, where heat and pressure are unimaginably intense, new elements are born. Carbon, oxygen, nitrogen. These come from stars like our sun during their long, steady lives. Heavier ones, like iron, nickel, and gold, require more dramatic events. Supernovae, the violent deaths of massive stars. When a star explodes, it scatters its creations into space, seeding the galaxy with the raw materials for planets, oceans, and living things. Every atom in your body heavier than hydrogen was made in a star. The calcium in your bones, the iron in your blood, the phosphorus in your DNA, all forged in stellar furnaces, then carried across space, until they found their way into a newborn Earth. This is how the universe remembers, in the elements themselves. When scientists point a telescope at a distant star, they can read its composition from the light it emits. Every atom absorbs and releases light in its own distinctive way, leaving a pattern of bright and dark lines in the star's spectrum. It is a barcode of the cosmos, a unique chemical signature that tells you where the star has been and what it has made. Through these spectral fingerprints, we can tell which stars are young and which are ancient. Older stars have fewer heavy elements because they were born when the universe had not yet made many. Younger stars, like the Sun, contain more metals and complex elements because they were born from clouds already enriched by the ashes of earlier generations. Even galaxies carry chemical memories. Some are rich with heavy elements, their stars young and metal bright. Others are poorer, containing stars that date back to the early days of cosmic history, when hydrogen and helium were nearly all there was. The distribution of these elements tells a map of movement and mixing, which galaxies collided, which merged, which have been quietly evolving in isolation. Sometimes, the chemistry tells of more specific events. Astronomers have found stars with unusually high levels of certain elements, like europium or strontium, which point to rare, cataclysmic origins, neutron star mergers, or exotic supernovae. These are not just chemical curiosities. They are footprints of once-in-a-billion-year events, recorded in the hearts of stars that still shine today. Even our own solar system carries such clues. Meteorites, those rocky messengers from space, contain isotopes that reveal the conditions of their birth. Some isotopes are short-lived, which means they must have been created in a nearby supernova, shortly before our solar system formed. It is as if the sun and planets were born, in the glowing aftermath of a cosmic neighbor's final act. And here on Earth, the chemical archive continues. In the deepest layers of rock, trapped atoms tell of ancient bombardments, of shifts in the sun's activity, even of rare cosmic rays from faraway explosions. The very crust of our planet is like a notebook written over billions of years. Each mineral vein a sentence, each fossilized isotope a word. It is remarkable to think that the universe does not remember in stories as we do, but in substance. Its memory is solid, woven into the matter we can touch, hold, and breathe. And yet, when we decipher it, we find that these chemical clues form a narrative every bit as rich and intricate as any human history. There's also something deeply humbling in this chemistry of remembrance. It tells us that nothing is truly new. The atoms in the air you inhale tonight were here long before you, and will remain long after. They have been part of countless other forms: a stone in a riverbed, a leaf on an alien world, the skin of an ancient creature that lived and died before our planet had continents. When you drink a glass of water, some of those molecules may have passed through the lungs of dinosaurs or through the ice of a comet that once wandered the far edges of the solar system. When you touch your hand to your heart, the iron beneath your skin may have been born in a star that died before the sun was even a cloud of gas. And all this recycling of matter and energy, is not chaos, but continuity. It is the cosmos keeping its memory alive, passing it forward, through the quiet, patient work of chemistry. If you look up tonight and see the cold, sharp glint of a distant star, know that you are not just seeing light. You are looking at a page in the universe's autobiography. The words may be written in hydrogen and helium, carbon and oxygen, but if you read carefully enough, you can trace the plot all the way back to the first chapters. Some memories are loud when they are made, shouts in the dark, flashes in the night, but they fade into silence as the years pass. Only the scars remain, quiet and unmoving. Yet speaking of what once was, the universe has scars too. Some are so large we can see them from space. Others are so ancient that they've worn smooth under the slow hands of time. And yet, all of them are records of events too powerful to forget. A crater is the most honest of cosmic memories. It is the mark left when something falls from the sky and strikes a surface with the weight of its journey. On the moon, these craters are everywhere. Thousands upon thousands of them, from small pinpricks to vast basins hundreds of kilometers wide. Each one is a frozen instant, a single moment of violence, preserved for billions of years. The moon keeps these marks well, because it has no wind, no rain, no flowing rivers to smooth them away. It is like a photograph that never fades, an album of impacts, stretching back to the earliest days of the solar system. Earth also has craters, but here, the memories do not last so long. Our planet is restless. Weather, water, and shifting land soften or erase the scars. Mountains rise, seas retreat, forests grow over the wounds. Yet, some remain, like whispers from deep time. One such whisper is the Chicxulub crater in Mexico, over 180 kilometers wide, born from the impact of a massive asteroid about 66 million years ago. Its arrival was swift, a streak of light in the sky, a moment that outshone the sun, and its consequences vast. The shock waves traveled the world, dust blotted out the light, and much of life as it was then came to an end. The dinosaurs, along with countless other species, were swept from the stage, leaving room for new actors to emerge. The Earth remembers this not just in rock, but in the thin, dark layer of iridium-rich clay, found in sediments across the globe. Iridium is rare on Earth's surface, but common in asteroids, a chemical fingerprint of the visitor from space. Other worlds have their own tales. Mercury, baked by the sun, is a planet almost entirely covered in craters. Mars bears the ghostly outlines of ancient impacts, some of which may have shaped its climate forever. Even the icy moons of the outer planets wear their scars, but here ice flows slowly, and craters can blur into strange, softened shapes under the quiet pressure of time. Not all cosmic scars are craters. Some are rings, not carved into a surface, but drifting in the cold black between planets. Saturn's rings are perhaps the most famous, bright and delicate, yet born from violence. They may be the remains of a shattered moon, torn apart by Saturn's gravity long ago, or the debris of icy bodies that wandered too close. What we see now as beauty may have begun as catastrophe. These rings are made of countless pieces, chunks of ice and rock, ranging from grains of dust to house-sized boulders, circling endlessly, reflecting sunlight in pale, ghostly bands. From afar they look smooth, but up close they are chaos made orderly, a kind of dance that will not last forever. Over millions of years, the particles will drift away, fall into Saturn, or merge into new moons. Even this scar will one day heal. There are other, stranger marks. The great basins on Mars that hint at lost oceans, the tilted axis of Uranus, likely the result of a colossal collision, the oddly fast spin of some asteroids, spun up by past encounters. Each is a reminder that the solar system's history was not a gentle one, and beyond our planetary neighborhood, the very shapes of galaxies carry memory. When two galaxies collide, their stars rarely crash into each other. The spaces are too vast, but their gas and dust twist into new forms, and the galaxies themselves are reshaped. Some become long, tidal streams of stars. Others form dense, brilliant cores. The light from these altered galaxies is a record of a meeting that may have happened hundreds of millions of years ago, still visible to us now. On every scale, from the curve of a ring to the crater in a hillside, the universe writes its history in its wounds. It does not hide them. It does not erase them. Instead, it lets time soften them, so that when we finally notice, we see not just destruction, but transformation. Because a scar is not only proof of an injury, it is proof of healing. The moon's craters have become markers for navigation. Saturn's rings have become an icon of beauty. The asteroid that ended the dinosaurs' reign paved the way for mammals, and eventually, for us. Perhaps that is why there is a quiet comfort in knowing that the universe keeps its scars. They are not there to make us afraid of what has happened, but to remind us that even the greatest catastrophes can give rise to something new. And when you look up into the night sky, you are seeing those scars from a safe distance, reading them like lines on an ancient map. You are looking at a cosmos that remembers, not in anger, not in grief, but simply as part of its endless unfolding story. Some memories are not carved into stone or ice. They do not sit still for us to find. Instead, they drift, endlessly, quietly, tracing the same paths again and again, as if walking in circles to keep from forgetting. In space, these paths are orbits, and they are among the most delicate records of the past. An orbit is not just a line drawn by gravity, it is the echo of an ancient meeting, a conversation between two bodies that decided how close they would dance and how far apart they would drift. Every planet, every moon, every fragment of rock in the solar system follows a path set long ago. Some were born in place, their orbits shaped in the cradle of the early Sunday. Others were captured, wanderers from far away, pulled into the embrace of a planet or star, and set into motion like a bead on an invisible string. These paths remember encounters that may have lasted only moments, but changed everything. A passing asteroid that veered too near to Jupiter might have been thrown into a new trajectory, never to return to its old one. A comet brushing past a planet could have its orbit stretched into a long ellipse, so that it now spends centuries far from the sun, before rushing back for another brief hello. Some of these paths are peaceful, near-perfect circles that speak of stable relationships. Others are elongated and eccentric, like the signatures of restless souls. And some are chaotic, twisted by multiple encounters over time, so that they seem almost unpredictable. A reminder that even in the vastness of space, chance meetings can alter destinies. The moons of the outer planets carry especially telling orbits. Some, like Jupiter's Galilean moons, are locked in a resonance, a repeating pattern where their positions line up in the same way over and over. This rhythm is no accident. It is the frozen trace of a long-ago dance when gravitational tugs slowly pulled the moons into perfect step with one another. Other moons have stranger paths. Neptune's largest moon, Triton, orbits backward, a rare motion called retrograde orbit, suggesting it was not born around Neptune at all. Instead, it was likely captured from the Kuiper belt, a wandering body pulled in, and forever altered by a single encounter. Its path today is the quiet, unending retelling of that moment. Even the faint rings around planets tell orbital stories. The particles in Saturn's rings, though they may shift and swirl, still follow the same general curves set by the gravitational influence of the planet and its shepherd moons. The gaps within the rings, like the dark Cassini division, are places where orbital resonances have swept particles aside, a silent signature of forces at work for millions of years. Beyond our solar system, orbits still whisper their histories. Binary stars, pairs bound by gravity, circle one another endlessly, their motions betraying their masses, their distances, and the story of how they came to be. Some pairs are wide and slow, likely formed together from the same cloud of gas. Others are tight and fast, perhaps drawn together later, through a gravitational meeting in in a crowded cluster. Even galaxies orbit. The Milky Way and the Andromeda Galaxy are on a slow, inevitable collision course, drawn together by gravity over billions of years. Their stars will mostly pass each other unharmed, but their shapes will be forever changed. And long before that final embrace, their motions already speak of their future, a faint, cosmic whisper we can hear by measuring the tiniest shifts in light. Here on Earth, we have learned to listen to these whispers. Spacecraft like Voyager, Cassini, and New Horizons have used the gravity of planets to slingshot into new trajectories, mimicking the same ancient encounters that shaped asteroids and comets. By tracing these paths precisely, we can uncover the forces at play, the invisible tugs and pulls that are otherwise only hinted at in the quiet sweep of an orbit. There is a strange poetry in the way these paths persist. They are not like scars, which stay still and wait to be seen. They are moving memories, loops and curves that repeat, as if time itself were holding on to the shape of an event. When you look at the moon tonight, know that its perfect dance around the Earth is a memory of its birth. It may have been formed from the debris of a colossal collision with a Mars-sized body, billions of years ago. That moment is gone, but its trace, the moon's path through the sky, is still here, a reminder written not in rock or dust, but in motion. And perhaps that is the most enduring kind of memory, one that is alive, repeating itself endlessly, changing only in the subtlest ways. Orbits remind us that the universe does not just record the past in static form, it can weave it into ongoing movement, so that the act of remembering is also the act of continuing. The next time you trace the slow arc of a planet across the night, or watch the glitter of a satellite drift overhead, think of these as lines on an invisible page, a story still being written. Each time the object circles back to where it began. Some fossils rest in stone, buried beneath the weight of ages. Others float in glass cases, delicate and still. But some, the oldest of all, never stop moving. In the language of the universe, light is a messenger, and its journey can outlast the very places it came from. It carries not just energy, but history, preserving the shape and colour of a moment long gone. When you look up at the night sky, you are not seeing now, you are seeing then. The light from the moon took just over 1 second to reach you. The sunlight warming your face left the sun about 8 minutes ago. The nearest star after our sun, Proxima Centauri, is more than 4 years away in light's measure. So the faint glimmer we see tonight began its journey before some of your recent memories were made. Go farther, and the distances become dizzying. The Andromeda Galaxy shines at us from more than 2 million years ago. That means the light entering your eyes tonight set out long before humans walked the Earth, long before any city or language existed here. These are not just pretty numbers. They are proof that light is the universe's time capsule. Each photon, each particle of light, is like a traveller that never slows, carrying with it the exact conditions of the moment it left its source. The colour, the brightness, even the subtle stretching of its wavelength. It can tell us how far it has travelled, and how much the universe has changed in that time. In this way, telescopes become archaeologists. They do not brush dust from old bones. They catch light in mirrors and lenses, decoding the stories locked inside. When astronomers point their instruments at distant galaxies or nebulae, they are digging through layers of time, the farthest layers being the oldest. There is something humbling in realizing that the farther we look, the younger the universe becomes, not because time is reversing, but because we are seeing its earlier chapters still streaming toward us. Some of the most ancient light we can detect is called the cosmic microwave background, the afterglow of the Big Bang itself. It is everywhere, faint and cold, whispering from every direction. This light has been travelling for nearly 14 billion years, crossing a universe that has stretched and grown around it. It is the closest thing we have to a baby picture of the cosmos, a fossil, still in flight. But ancient light isn't always so faint. Sometimes it bursts into our skies unexpectedly, as in the case of supernovae, the colossal deaths of stars. When a massive star explodes, its light can outshine entire galaxies, traveling across space for millions of years before arriving here. And when it does, it's as if we are watching a firework from impossibly far away, its flare delayed across deep time. There is a bittersweet truth here. Some of the stars you see tonight may no longer exist. Their light is still en route, faithfully completing a journey from a source that has already burned out. You are looking at their last words, spoken long ago, finally reaching your ears through the dark. Even closer to home, this principle holds. The glow of the sun on a clear morning is already a story from 8 minutes earlier. The colors of a sunset are the final lines of a message that has been altered by the thickness of our atmosphere, filtered into reds and golds before it finds your eyes. We have learned to read these messages with precision. Spectroscopy, the art of splitting light into its colors, lets us see fingerprints of the elements within a star. We can tell if a star has more hydrogen or helium, if it's young or old, and even if it's moving toward or away from us. The stretching or compressing of its light, known as redshift or blue shift, is the imprint of motion, a subtle note about the dance between us and the source. In this way, light is not only a fossil of the moment it left, it is a fossil that changes as it travels, stretched by the expansion of space itself. Distant galaxies appear redder than they truly are, because the very fabric of the universe has pulled their light apart on the way to us. There is poetry in the fact that, while everything else ages as it moves forward in time, light carries the image of a moment exactly as it was. A photon that left a star 10 billion years ago is the same photon that might strike your eye tonight, unchanged in its message, though the star itself may have changed beyond recognition. Sometimes, when you stand outside on a clear, quiet night, you can feel the weight of this. You are not just surrounded by stars, you are surrounded by arrivals, some fresh from nearby, others having travelled for most of the age of the universe, to meet you here, now. The thought can be dizzying, but it can also be grounding. It means that the universe is, in some way, constantly in conversation with itself. A galaxy's ancient light may fall on a young planet, just beginning its own story. The glow from a dead star might inspire life on a world far away. And here you are, standing at the end of one of these journeys, holding the final link in a chain that began before your world was formed. In catching the light, you become part of its history, and it becomes part of yours. When you think of memory, you might imagine a photograph, a page in a diary, or a story passed down from one voice to another. But the universe has a way of storing its past that is neither paper nor picture. It is in the bending of space itself. Gravity, in its quiet and patient way, can hold on to an event long after the moment has passed, not just by keeping planets bound to their stars, or moons to their planets, but by leaving subtle curves in the invisible fabric of reality. Space is not an empty stage. It is more like a vast, flexible sheet. Place something massive on it, a star, a planet, a black hole, and the sheet dips and warps. Other things nearby respond, sliding along those curves, their paths forever altered. But here's the part that feels like a whisper from the past. Even when the actors leave the stage, the ripples can remain. The most dramatic example of this comes from events so violent that they send waves through space-time itself, gravitational waves. When two massive objects, like black holes or neutron stars, spiral into each other and merge, they release a surge of energy that ripples outward at the speed of light. These waves don't carry light or matter, but the memory of the collision, a precise record of its rhythm, its power, its final, inevitable moment. For most of human history, we couldn't hear these echoes. They passed through us unnoticed, stretching and squeezing the very space we inhabit, by amounts smaller than the width of a proton. But in 2015, humanity finally caught one. Deep in the quiet of the LIGO detectors, two immense L-shaped observatories, built to measure the smallest imaginable shifts, a tiny tremor arrived. It was the signature of two black holes, merging over 1 billion years ago. By the time their signal reached us, life on Earth had only just begun to take its first complex forms. And yet here it was, a faint shiver in the fabric of reality, telling us of an ancient event with perfect clarity. These waves are not just vibrations, they are storytellers. From their shape and timing, we can deduce the masses of the objects that made them, how far away they were, and even how they spun as they danced their final steps. Each wave is a time-stamped message, like a letter sent before humans existed, arriving just now in our detectors. But gravity doesn't need such violence to remember. Sometimes, the shape of an orbit, or the speed of a star, is enough to tell the story of a long-gone encounter. A star moving faster than its neighbors might have been flung by the slingshot of a passing black hole. A cluster of stars bent into an arc might have been stretched by the pull of a galaxy that drifted too close. In these cases, the memory is written not in light, but in motion, in the way matter continues to move, under the influence of an event that is no longer happening. Black holes are perhaps the ultimate keepers of gravitational memory. They are born from the collapse of massive stars, their mass so concentrated that nothing, not even light, can escape. What makes them remarkable is not only their density, but the way they carry the past with them. Every black hole remembers, in its mass and spin, the stars that formed it, and any companions it has consumed. It is as though they keep a silent, unchanging ledger, a sum total of all that has fallen in. Some scientists speak of the no-hair theorem, the idea that black holes can be fully described by just 3 numbers: mass, spin, and electric charge. And yet, within those numbers, is compressed the entire history of their making. Every atom, every photon that crossed the event horizon is part of that story, though we may never read it directly. Even light itself can be bent by gravity, arcing around massive objects in a phenomenon called gravitational lensing. This bending is not a trick of the eye. It is the result of space being curved by mass. And here is where gravity's memory becomes even more intriguing. When light from a distant galaxy passes by a massive cluster of galaxies, it can be split into multiple paths, arriving at different times. Some of the images we see today may be years, decades, or even centuries apart in their journey, even though they came from the same source. The universe can show us the past and, later, past, side by side, thanks to the way mass holds onto and delays the light's arrival. Imagine a mountain range in space-time, with valleys and ridges carved by mass over billions of years. Light and matter alike must follow the curves, their paths forever altered, even if the thing that shaped the land has since changed or moved on. In this way, the memory of mass is persistent. A galaxy that collided with another long ago may leave behind streams of stars, still tracing the arcs of their disrupted paths. A dark matter halo, invisible but massive, can shepherd galaxies into clusters, its presence known only through the way it bends space around it. Gravity's memory is not as obvious as a photograph, nor as colourful as light. It is a memory written into the invisible structure of the universe, waiting for careful eyes and instruments to trace its meaning. And perhaps that's why it feels so intimate. Light can dazzle us and fade. Matter can shatter or drift away. But gravity keeps its hold, as though the universe itself cannot quite let go of the weight of what has happened. The next time you feel the pull of the earth beneath your feet, remember that this same gentle force is the keeper of some of the oldest secrets in existence. It has shaped the paths of moons and planets, curved the journeys of light and stars, and carried the echoes of collisions across billions of years. When you close your eyes tonight, imagine that quiet, endless sheet of space-time, dimpled and rippled by every star, every planet, every dance of mass the universe has ever known. In its curves is the story of everything, a memory so vast that we are only just learning to listen. If light is the messenger of the cosmos, and gravity is its quiet archivist, then cosmic dust is the forgotten librarian, small, unassuming, and yet holding stories, so old that they predate our Sunday. We tend to think of dust as something ordinary, something we brush off our shelves without a thought. But in space, dust is ancient. It is the ash of stars, the crumbs left behind after worlds are built, the quiet residue of collisions and births that shaped the universe. These particles drift between stars, float in the glow of nebulae, and sometimes settle into the atmospheres of planets like ours. They are smaller than a grain of sand, often no bigger than a speck of smoke, but within them are minerals forged in furnaces. Billions of years ago, some of the dust that falls through our atmosphere each day is older than Earth itself. These motes have wandered the galaxy for eons, passing near supernovae, skirting the edges of black holes, weaving between the spiral arms of the Milky Way. Each collision, each encounter, changes them in ways too subtle for the eye to see, but their atoms remember. Scientists call these grains prosolar dust. When they are found in meteorites, they can tell us about the chemistry of the universe before our sun was born. Inside them are isotopes, variations of elements that act like fingerprints. These fingerprints match no rock on Earth, no material formed here. They are proof that these particles, who were once part of other solar systems, now long gone. Imagine holding in your hand a piece of matter older than the planet beneath your feet. You could crush it into powder and never know its journey, but with the right instruments, its story comes into focus. In its composition are clues to the kinds of stars that gave it birth, the temperatures it endured, the radiation it absorbed, the collisions it survived. Cosmic dust gathers in unexpected places. On the moon, a layer of fine grey powder, regolith, is mixed with particles from space that have been settling for billions of years, untouched by wind or rain. On the icy plains of Antarctica, scientists find tiny metallic spherules that fell from space, their surfaces melted smooth by the heat of entry. And in the cold depths of the ocean, dust drifts down slowly, joining sediments that build layer upon layer. In some of these layers, scientists have found iron isotopes that can only be made in supernovae. This means that millions of years ago, a star exploded somewhere in our cosmic neighborhood, and Earth was dusted with its ashes. In this way, particles act as messengers of events we never witnessed. They bring with them the signature of their origins, not in the form of a clear picture, but as a coded pattern of atoms that we can learn to read. But dust does more than record the past. It also shapes the present. In space, clouds of dust block starlight, casting dark silhouettes against the glow of galaxies. These dark clouds, dense with particles, are the birthplaces of new stars and planets. They gather gas and material, cooling and collapsing under their own gravity, until light is born again within them. It is as if the librarians of the universe not only keep old books safe, but also provide the paper and ink for new stories to be written. Sometimes, dust holds memories in motion. The rings of Saturn, from a distance, who look like smooth bands of light, but up close, they are made of countless icy particles, each one reflecting the history of impacts, collisions, and rearrangements. Some have likely been there for hundreds of millions of years, witnessing the slow dance of moons and the tug of gravity. Even the air we breathe contains traces of cosmic dust. Micrometeorites fall onto every square meter of Earth each year, invisible unless caught on special collectors, or spotted against the snow. Each one is a visitor from elsewhere, a small reminder that the solar system is not sealed away, but part of a larger, ever-moving exchange. The most remarkable thing about these dust librarians is how quietly they work. Unlike stars, they don't shine. Unlike planets, they don't dominate the landscape. They are patient keepers, content to wait billions of years, until someone, or something, comes along to read their archive. When we study them, we are not just learning about where they came from, we are touching the record of the universe's ongoing life. We are holding evidence that nothing in the cosmos is wasted, that even the smallest fragment has a place in the great cycle. It is humbling to think that while we strive to write history in books and data files, the universe writes its own in mineral grains and ice crystals. No one assigned this task to the dust, but still it keeps the record, faithfully, endlessly, even as it drifts. So the next time you see sunlight streaming through a window, and the air is full of tiny floating motes, pause for a moment. Some of those motes may have been part of a rock, shattered on a distant world. Some may have drifted through the tails of comets, or wandered the dark between stars. They are the quiet librarians of the universe, and in their unassuming way, they are keeping time. We often imagine time travel as a sudden leap, a flash of light, a doorway into another era. But in truth, time travel happens every night, when we look up at the stars. The difference is that our machine is not made of steel or circuits. It is built of mirrors and lenses, crafted to catch the oldest light still drifting toward us. A telescope is a time machine that doesn't move you at all. It brings the past to you. Every point of starlight you see is already an echo, but the naked eye can only gather so much. With a telescope, that echo sharpens, and details begin to emerge. The spiral arms of galaxies, the glow of nebulae, the faint smudge of a cluster whose light left before our species existed. Telescopes are not windows. They are funnels. They pull in photons, particles of light, that have been traveling for millions or billions of years, and they concentrate them into an image that your eye or camera can hold. When astronomers say they are looking farther into space, they also mean they are looking farther into the past. Because light takes time to travel, distance and history are bound together. The farther away an object is, the older the light we see from it. With the right telescope, you can witness the birth of stars in clouds of dust, watch galaxies colliding in slow motion, or glimpse the faint afterglow of the Big Bang itself. All of this is long over in real time, but for us, it is still unfolding. The largest telescopes on Earth, with mirrors the size of small buildings, are like deep wells into the night. They are designed to drink in even the most reluctant light, pulling it from the edges of the observable universe. Some are placed high on mountains, above the thickest layers of air, to avoid the blurring effect of our atmosphere. Others float in space entirely, like the Hubble Space Telescope, free from the shimmering distortions of Earth's sky. Hubble has shown us galaxies so distant that their light has been on the road for more than 13 billion years. In those images, we are looking at a universe barely 500 million years old, a young cosmos still in its early chapters. And then came the James Webb Space Telescope, its great golden eye unfolding far from Earth. Webb peers in infrared, a wavelength that can slip through dust clouds and reveal what visible light cannot. It has shown us stars in their infancy, galaxies taking shape, and the faint reddish glow of the earliest structures in space. Every telescope is tuned like an instrument, designed to catch a certain song from the cosmos. Some listen to radio waves, the deep bass notes of the universe. Others capture X-rays, the sharp flashes of its most violent events. Together, they make a symphony of observation, each part revealing a different chapter of the same ancient story. To use a telescope well is to understand patience. The exposure may take hours. The images may need days of processing. And even then, what we see is not the whole truth. It is the truth filtered through the lens of time and distance. But this filtering is what makes it precious. You are not seeing what is. You are seeing what was. And in doing so, you are reminded that the present is just a layer in an unending stream. Even small backyard telescopes are capable of this magic. Point one toward Jupiter, and you will see the planet's cloud bands as they appeared tens of minutes ago. Aim it at a globular cluster, and you will be looking at hundreds of thousands of stars, whose light set out tens of thousands of years before humans tamed fire. Through a telescope, distance becomes intimacy. You might be separated from a galaxy by millions of light years, but in the eyepiece, you share a direct connection, a photon's final moment of travel ending in your gaze. It is easy to forget that our own eyes are telescopes of a sort. Limited in aperture, yes, but still capable of catching ancient light unaided. The telescope is simply an extension, a way to make the faint brighter, the small larger, the old nearer. This is why astronomers often say that looking through a telescope is like opening a letter sent long ago. Some of those letters were written before Earth's continents had their current shapes, some before our sun had even reached its stable middle age. And every night, new letters arrive. Light from supernovae exploding in distant galaxies, light from comets swinging around alien stars, light from planetary systems forming far away, their young suns lighting up the dust around them. We cannot go to those moments, but we can let those moments come to us. Each image captured in a telescope is a kind of archaeology, an excavation of time itself. The irony is that the more we look back, the more we learn about the present, because the structures we see in their youth are the same kinds of structures that surround us now, grown older and more complex. And so the telescope becomes more than an instrument. It becomes a mirror, showing us not just the cosmos as it was, but the cosmos that made us, and the cosmos we are still becoming. If you could hold the universe in your hands, you might expect it to feel vast and empty, but it would not be hollow. It would be heavy with memory. The cosmos does not write history in ink. It writes it in motion, in the faint warmth of ancient light, in the shapes of worlds, and in the silence between the stars. Every collision leaves an echo. Every birth leaves a trace. Every ending ripples outward, its signal carried on in ways both obvious and hidden. This is why, in a sense, the universe never forgets. A supernova that exploded millions of years ago still scatters its elements through space, seeding clouds that will one day make new stars. The light it gave off still travels, crossing distances so great that someone in another galaxy might only now be seeing its final flash. A comet that once swung past our sun and disappeared into the dark still leaves its signature in the fine dust. It's sprinkled into our skies, dust that burns each year as meteor showers. We can stand under and watch. Even gravity is a record keeper. Mass bends the paths of objects and light, leaving behind distortions like fingerprints in the shape of space itself. Wherever something massive has passed, the curvature lingers, reminding the universe of the event. And then there are the stories, locked in the surfaces of worlds. Craters on the moon still bear witness to the ancient chaos of a time when planets were young. The icy scars on Europa hold the memory of tectonic shifts beneath a frozen ocean. Mars keeps the outlines of riverbeds that have been dry for billions of years. Memory is not always active. Sometimes it is quiet, folded into the structure of things. But it is there, waiting for those who know how to read it. On Earth, we join in this act of remembering. We look at tree rings to read the rhythm of seasons past. We study layers of rock to find the shadow of extinct creatures. We examine grains of cosmic dust that wandered here from other solar systems. It is humbling to realize that even as we remember the universe is remembering us. Long after our buildings crumble and our languages fade, there will still be traces. The radio waves we send into space will keep moving outward, passing between stars. The changes we make to the chemistry of our atmosphere will be written into ice layers for future eyes to find. In this way, memory is not an act of will for the cosmos. It is simply its nature. Matter and energy cannot exist without leaving a mark. Every photon, every atom, every ripple of gravity is part of an ongoing record, not in words, but in form and pattern. And so, when we look up at the night sky, we are not only seeing beauty, we are reading the diary of existence. Each star is a chapter, each nebula a paragraph, each galaxy a sprawling, unfinished epic. We arrive late in the story, but the book is still open, and we are allowed to turn the pages. Perhaps that is why the night sky feels so strangely familiar. Even without understanding the science, some part of us recognizes these ancient traces. They stir a quiet sense of belonging, as if we too are pages in the same cosmic volume. The universe remembers in light and shadow, in dust and stone, in the soft bending of space, and the endless, patient travel of time. It remembers not to cling, but simply because memory is woven into what it is. And when our time comes to leave, we too will become part of that memory. Our atoms scattered into new shapes, our energy shifted into new forms, our influence written subtly into the fabric of space. This is not something to fear. It is something to rest in. Because if the universe never forgets, then in some way, nothing is ever truly lost. So as you lay here now, eyes heavy, breath slow, imagine that you are floating just beyond Earth, looking down at the blue curve of the planet. Below you, the oceans breathe, clouds drift, cities glow faintly in the dark. All of it is part of the record, this moment included. And now, you can let your own mind set its pen down. Let your thoughts soften and dissolve into the gentle flow of the present. The universe will remember this moment for you. You can let it go. In the quiet that follows, stay with me just a little longer. The music will play soon, a calm tide of sound to guide you into sleep. Let the tones wrap around you, like the darkness between stars, soft and infinite. Close your eyes and drift. The universe has the watch tonight. Good night.